This video is to help you understand the different features of a trigonometry graph or a sine graph. So the first thing to know is the basic shape of sine. Okay, it is always starts at 0, 0, goes up, reaches its maximum, passes down, reaches its minimum, and back up. And then this pattern repeats over and over again because sine is periodic. Now, when you're trying to find the different features of a sine graph, the first thing that I always find is the midline. The midline is a line that passes from the start and the stop of one curve. Okay, it intersects the graphs 3 times. Okay, this midline is on the x-axis. I would say the midline is the line y equals 0. But that's not always the case, depending on if your graph has experienced any transformations, shifting up, down, right, or left, okay? Another feature of the graph is the amplitude. This is the height of the curve. It's from the midline up to the maximum, measured in the y values. It equals a in the sine equation. Y equals a sine of k parentheses x minus c plus h. So the amplitude, again, is the height. It's measured in terms of y values. If you look on this graph, you go over to the y scale, and it reaches a height of 1. Height is always absolute value, okay? The only time it's a negative is if the graph is reflected. Another feature of the sine graph is the period. The period, not k, okay, is the formula period equals 2 pi divided by k. We can use this formula to solve for k or solve for the period, depending on what you're given. All right, the period is the length that it takes from the start to the stop of one sine curve. Traditionally, this is 2 pi, okay? You take the x2, which is down here, minus the x1 to calculate the length of the period. Again, in this sine curve, the period is 2 pi. Okay? Now, k is called the frequency. It is how many sine curves are within that specific period 0 to 2 pi. Since the period is 2 pi, then when we plug 2 pi into the period equation, we get 1 for k. This is not always 1, nor is it always 2 pi. You have to look very carefully at what scale your x-axis is in. Another feature are the vertical and horizontal shifts. So what I want you to notice about this graph before I explain is the scale, okay? It cut off a little bit, but here's 0, 0. Okay, right up here in this top left-hand corner. So we are in the 4th quadrant. So our x's are positive and our y's are negative. Okay. Now, for the first thing I would do is identify the midline. So sketch that midline through the graph so it cuts right down the middle. Then I want you to identify a sine curve, the first one you come across when you're moving to the right of the y-axis. So this is not a sine curve, this down here, okay? A sine curve always starts at the midline, goes up, cuts down, and back. Then I want you to name that point of intersection. Now I'm sorry it cut off a little bit, but we can tell by the scale going up here that halfway in between 2 and 4 is 3, and this is 2, 4, 6, so this is the point 3, negative 6, okay? Finding that point is going to help you with the phase shift and the vertical shift. The x-coordinate is your phase shift. It's right 3. And the y value is your vertical shift, or down 6. Now, when we plug these into the equation, the formula is x minus c, so it's x minus 3. If you had phase shifted to the left, and you had let's say your point was negative 4, then it would be x minus a negative 4, which becomes x plus 4. And then your vertical shift is the value of h, and that is negative 6. So if you look at it as a whole, okay, phase shift is the distance from the y-axis, the vertical shift is the distance from the x-axis, amplitude is the height, it's not always 1, And the period is the length that it takes to complete one sine or cosine curve. In this graph, they're talking about this shape down here, which is a cosine shape, like a U. Use your notes, check your formulas, and email me with any questions.